Good morning, guys. So this morning, we're going to look at algorithms. We're going to look at what are algorithms and the different ways that we can express our algorithms. So just to do a short recap, at this point, you should already know how to look at a problem and be able to break down that problem into three main blocks, namely input, output, and processing. We should know what a variable is, we should know what a constant is, and where and when we use constants. We should already know what data types are when working with programming. Let's look at what algorithms really mean. So as we have stated, an algorithm is really a series or a sequence of precise instructions that, if followed, produce a result to a given problem. Right? One of the things that we have to bear in mind is that the algorithm has to have a finite amount of steps, meaning we cannot create an algorithm that go on forever in a forever loop. Right? It must have a beginning, and the algorithm must have an end. So that means that whatever problem you're trying to solve, you must have a start, you must have where you start, and then it must have an end, a complete end. Or else we'll have what we call an infinite loop, which will eventually crash your machine. Alright, so these steps, which we call algorithms, they can be represented in two ways. They are either using pseudocodes or using what we call a flowchart. Now, what is pseudocode? Pseudocode is pretty much English-like statements that are used to define an algorithm. So when we look at pseudocodes, one of the things that we're going to notice is that it's basically human readable, right? However, and also it looks like code, like programming codes. However, this type of code cannot be run on a machine. They are only for human consumption. Then they're only for human consumption. So you use pseudocodes to sort of have a feel or a understanding of how a program will function. But those codes cannot be run on any machine. So keep that in mind. While writing pseudocodes, bear in mind that it must have a start and a stop, as every algorithm, as we indicated early on, that a algorithm has to have a start and it must have an end, right? So we use start and stop to denote the beginning and the end of our algorithm in a pseudocode. If we have any variables that we need to initialize, we need to include it at the top of our pseudocode, just below the start. Right? They are considered declarations. So basically, that's where you declare your variables on them. Alright, so why do we declare our variables or we initialize them? So let's say, for example, you have a software or a program that calculates the amount of money earned for the day, right? At the beginning of the program, you may have a balance from yesterday. So let's say, for example, the balance is $25. You want to initialize it and probably put at the top balance equal 25, right? Which indicates that you have $25 left off from yesterday. So you start off with $25. So that's where initializing comes in. So you initialize your program with variables at the top of the pseudocode in the declaration area, right? You then have the body area, where you basically put in the codes or the instructions for your program. Now, we also said that an algorithm can be expressed as a flowchart. And here we have it. A flowchart is basically a pictorial way of representing an algorithm using a set of standard symbols or shapes. All right. So with flowchart, we use symbols. And here are some of the symbols. We have the start symbol. So the start and the stop symbol are sort of oval shape. And they will normally include the word start and stop at the beginning and the end, respectively, of our flowchart. And they are called terminators. We have the parallelogram, which denotes our input or output. So when expressing our algorithm using the flowchart, we use the parallelogram to denote our inputs and our outputs. We also use the rhombus, the diamond shape, to denote that whatever our code is doing right now is basically a decision, is making a decision. And we look at all of those later on. So remember that the rhombus or the diamond shape denotes that we actually making a decision there. And then we have the rectangle, which denotes that we actually running a process. So that will be our processing. And the rectangle represents process. And there's one other symbol that's not showing up in the diagram here, but you just need to take a note of it. You have a complete circle, and it represents a connector. So you can use it to connect different areas of your algorithms. But we'll look at that again closer as we move towards it. If we want newfound knowledge, let's go ahead and look at some of the problems that we had in the past that you solved. And let's look at it again, and let's go ahead and create different algorithms, right? And let's express the algorithms in flowchart or in pseudocodes. So let's look at the first problem. So the first problem tells us to design a program that accepts 3 numbers from a user. It's to find the sum of the 3 numbers and display the answer on screen. So that's something that we've dealt with already, so we know how to do that. So based on the problem, we can divide the problem into 3 different blocks or inputs and our outputs, we can see here it says accept 3 numbers, so we know that our program accepts 3 numbers. So we're going to create the variable names for that. So we create a variable name number 1, and number 2 and number 3. So each of those variables will hold the number that is supplied by the user, right? And it says to display the answer on screen. So we know that our output would be the answer, right? So our process would be finding the sum. So we can say as an answer is equal to num1 plus number2 plus number 3, right? And that will be our process. All right, so we already know that. So let's see how we can go ahead and all right, first of all, let's look at how we can express that in a different way, because as we said before, a problem can have more than one solution. So let's look at a second solution to that same problem. All right, here's a second solution to the same problem. On the inputs, we have number. On the process, we have repeat 3 times, and then we have the answer as output. Right, so that's the next way that we can express the problem, same problem. So let's see how we can go ahead and create pseudocodes from this IPO chart. We'll do that from the first solution. Okay, so we use the first IPO chart, and then we'll go ahead and create our pseudocodes based on that. So here's our pseudocode. So let me go ahead and explain. All right, so the first thing we know we should have is start and end, right? We must have a start and we must have an end. So that we know for sure. So you need to always remember that in your pseudocode, you must put a start and must put an end. That already is 1 mark, just having that, right? So the first thing we say here is print, right? And then it says enter your first number. If you remember the IPO table, on the inputs, we have 3 different variables. And as we can see, they are here in our pseudocodes. So why do we use print? And why do we use read? Right? So we use print to prompt the user, basically, or to output information on screen to the user. So that information could be instructions, or it could also be a result of a computation, right? So in that sense, we're asking the user to enter the first number. So we basically use the print command, right? Remember, again, pseudocodes are not actual codes, so they cannot be run on a computer. They are basically for human to be able to see and appreciate the flow of the program, right? So print says that we're printing something to the screen for our user. So what is it we're printing? You can realize that it's within quotations. We're printing to the user, enter your first number, right? So read. What does read says? Read says that you're accepting the information from the user in a variable, and you're basically reading it into the computer's memory, right? So when you see print, always remember that print, whatever comes after print, would be printed on the screen. It could either be instructions or it could be a result of a computation. So let's see what in our IPO table, we had 3 numbers, as we said. We had 3 variables. So basically, for every variable, the program is printing instructions on the screen for the user, asking the user to enter a number. right? So we see enter a number, a first number, enter a second number, and enter a third number, right? And after every print statement, we have a read statement, which actually read the number inputted by the user to a variable. So at this point, our number 1, number 2, and number 3 variable should all have a number input in memory, right? So what are we doing here? So answer is the next variable, and we are assigning num1 or number 1, number 2, number 3, the sum of it. I put it within brackets, which means that you do it first, but without the brackets, it wouldn't make a difference. If you look here, you'd see an arrow. That arrow basically says that you are assigning the sum of the values to the right. You are assigning it to the left variable, which is answer, right? In some pseudocodes, you would see an equal sign instead of a arrow. So in some of my codes, I'm going to put arrow, and some I'm going to put equal signs because they are interchangeable. So I want you to know that. So that's why you might see me put equal signs or arrows, right? So remember that answer there is a variable. And what we're doing, we are assigning number 1, number 2, number 3, the sum of it, to answer. And then here we come again, we're using that print statement or that instruction. And what it's doing now is printing the answer now to the screen. So just to recap, we use print when we want to print either instruction or a result of a computation to the screen. And we use read if we want to read in the information that is inputted by the user. All right. All right, let me show you a different version of that. Okay, let me go ahead and show you a different version. All right, so let's look at our pseudocodes here. Pseudocode 2, we have start, we have print. It says, so basically instructing the user to print 3 numbers. So we see the instructions here, enter your 3 numbers. And then for read, when it reads the variable, we actually accepting the 3 variables in memory in one line. So we have read number 1, number 2, and number 3, right? So we have number 1, number 2, number 3 being placed into the computer's memory in one line instead of having it done in 3 lines. So that's a different way of writing the same problem, right? And here we have the same process, which is we assigning the number 1, the sum of number 1, number 2, and number 3. We are assigning the sum of it to the variable name answer. And then we're printing off the answer to the user. And of course, we end in our program. Right? So I hope that you understand it thus far. So let's look at a third solution. As a third solution, we start with the name, with the keyword start, which is a terminator, as we see early on. And then we show a variable named count. So here we have count is equal to 0. So basically here we actually initializing our variable and saying that our variable is 0 at the beginning of our program. Then we use a keyword here, repeat, which means that whatever follow will be repeated. So what we're basically doing here is that, and one of the things to notice is the indentation. After repeat, I want you to recognize that we actually did an indentation, and then we put print, the print command, and then we say please enter a number, right? And then we have read, and we have read number. So what that does is from time we go to repeat, it prints to the user, enter a number, and it adds that number into memory, right? In the variable name number. Now what it does, it assigns the number to the variable name answer, right? And then it counts 1. So count we have here is 0. So count at this point, count is equal to 0 plus 1. So count is equal to 0 plus 1. Then it loops back up, or first of all it checks to see whether count is more than or equal to 3. So it checks that the variable at the start to check whether or not the variable is equal to 3, is more than or equal to 3. And if it's false, then it continues its cycle. So it repeats again, and it print that instruction to the user, enter a number, it reads that number into memory. See what it does here? It says the answer is equal to the answer plus the number. So basically all that line of code is doing, or that instruction is doing basically, is incrementing. So for every loop, it's taking that value and it's adding it to the existing values in memory. So whatever value that you start with, it adds it to the answer variable. So it does that 3 times based on the condition that we have at the bottom here, which says until the count is more than or equal to 3. So it loops, it goes through that instructions 3 times. And then on the 3rd time, it exits that loop, or that part of the code that indents, and then it prints out the answer that it has in memory to the user on screen. Right? So this one is a little bit different. This one uses a different sort of structure, because up until now we were using the sequence structure. But this sort of structure is what we call a loop, and this one is called a repeated loop, right? So that's a second structure, and we'll deal with structure a little later on, because there are 3 types of structure. There are the sequence structure, and the sequence structure, it follows lines of codes as they appear one line at a time in the sequence. And then we have the loops sequence, or the loop structure. And then we have what you call a selection structure, and the selection structure have to do with decision making. That is whenever you're trying to make a decision. That's why you use if statements, but we'll take a look at that later on. All right, so now we have it for pseudocodes. Let's see how we can express the same problem or the same algorithms. Let's see how we can express the same algorithm using a flowchart. All right, so here's our flowchart. We see that this symbol, the oval symbol, represents a terminator. It can either be a start or a stop. So again, we start our algorithm with a start. So we must put start. So we use a terminator here, and we inscribe start to it. So that means our algorithm starts here. As we said earlier, the parallelograms are used to denote input and output. So technically, if we look at our IPO or IPO chart, we realize that there's 3 variables. Number one, number 2, and number 3. Those are our inputs. So in the flowchart, you want to put all your inputs in your parallelograms, right? So we have here start, and then the arrow denotes also the flow of control. So we start, then we prompt the user, and we input a value, right? So that's why I have here prompt and input, meaning at that stage we prompt the user and we receive input from the user. So we have num1, num2, num3. Bear in mind there is no spaces, and it's the exact variable as indicated in the IPO table, right? Because the variable name is important. Even the case is important. So it has to be same case. If it's uppercase all, or if it's lowercase all, or the case, it's very case sensitive. So take that to mind. All right. So we have the inputs here in our parallelogram. So that denotes that this area is input. And then we have a rectangle, which denotes our processing. So that's where we put anything dealing with processing. So that is pretty simple. So basically, we use the information in our IPO table on the process. We place it in the process the rectangle. And then output. Again, we said that the parallelograms denotes inputs and outputs. So we label it as output, and then we put our output, which is answer. So that is the variable that we use for output. And finally, we terminate our algorithm with a terminator, and we label it as end, since that marks the end of our flowchart. All right, let's look at problem number 2. This is something that you came across already. It says to calculate 20% of the restaurant's bill and display the total. All right. So we have inputs, we have the bill, of course. We have output is the total. So we know the inputs and we know the output. And the process basically is to work out the difference between the input and the output. So there are several ways we can go about solving it, but that is just one of the solution. So we have our discount would be equal to 20% of 100 times the amount, right? So that will give us our discount. And then of course we would minus the bill from the discount and get the total. And the total we basically use in our output. So that we should already be clear on that already. Again, different. This is a slightly different solution from what I may have shown you before. Nevertheless, it solves the problem. So again, I purposely show you the different solutions to the same problem, so that you understand that a problem can have many different solutions. So expressing that algorithm as a pseudocode, we start with our first terminator, the start, and then we prompt the user, and we give the user instruction. The instruction we give the user is, please enter your bill amount. And the next thing we do, we accept the information in the variable name bill. So as we said earlier on, read is used to accept the information in memory. that the user type in. So whatever user type in is stored in the variable name bill. The second step, we go ahead and assign a variable name discount to hold the value of the percentage 20 over 100 times bill. So basically the 20% of the bill is stored in the discount variable. As you can see, that equal sign says it's assigned to the discount variable. Then we minus the discount. So whatever value is stored in the discount variable, we minus it, or we remove it from bill, which is the actual bill that was received from the user, the value stored in bill. And the total, we assign it, the total is assigned to print, to the print statement at the end, which means it prints it on the screen. So that prints the total on the screen, and then we end here. Pretty simple. And if we look at the flowchart, again, you begin with your terminator start, and then we have here prompt and input. So basically, instead of using print and read, we're using prompt. We are saying prompt and input, meaning that we're going to prompt the user, meaning that we're going to be prompting the user for an input, right? And the input would be stored in the variable name bill. Then, and that's part of our input, so that's why we have the parallelogram. And then the second box is the rectangle. And as we said, that a rectangle denotes a process. So your process would be done in the rectangles, and your output and input would be done in the parallelograms, right? So discount, we work out the discount. The discount is 0.20 times the bill. We'll give you the discount, and the total will be called the bill minus the discount. And then we output total in the last parallelogram, and we put here output, and then we terminate our algorithm with the terminator end. So this video was quite lengthy, but my whole point here is to get you to understand the whole concept of converting now your IPO table or your algorithms into a pseudocode or a flowchart. As with all the other videos, make sure you watch it a number of times. If you don't really get the concept at the first look, make sure you go through your notes, go through your textbooks, and rewatch the video until you get it, right? Because you need to understand that as we move forward. And if you are still a little bit clueless up to that point, I would advise you to go ahead and watch all the other videos before, and again with your textbook, and look at your notes, and make sure that you understand it. All right, I try the best on my end, and I hope you do the same on your end. All right,